The training of AI cameras involves a sophisticated process that blends hardware capabilities with advanced machine learning techniques. This process is designed to enable cameras to interpret, understand, and react to visual data in a manner similar to human perception, but at scale and speed that far exceeds human capabilities. The training involves several stages, each critical to the development of an effective AI camera system. Here's an in-depth look at how it's done. Number 1. Data collection. The first step is collecting a diverse and extensive data set of images and videos. This data set must cover a wide range of scenarios, objects, environments, lighting conditions, and perspectives to ensure the AI model can operate effectively in various real-world situations. For specialized AI cameras, such as those used in medical imaging or autonomous vehicles, the data must be even more specialized. Number 2. Data pre-processing. Once collected, the data needs to be prepared for training. This involves cleaning, removing corrupt or irrelevant data, labeling, annotating images with information about what they contain, and sometimes augmenting the data, creating artificially altered copies to increase diversity. Data augmentation can include adjustments like scaling, cropping, rotating, and changing brightness or contrast to make the model more robust. Number 3. Model selection. The next step is selecting an appropriate machine learning model. Convolutional neural networks, CNNs, are commonly used for image-related tasks because they are particularly good at picking up patterns in spatial data, such as the textures and shapes found in images. Number 4. Training the model. With the data prepared and the model selected, training can begin. This involves feeding the pre-processed data into the model, allowing it to make predictions about what it sees. The model's predictions are compared to the actual labels, and the differences, errors, are used to adjust the model. This process, known as backpropagation, gradually improves the model's accuracy. Training requires significant computational power and is often done on GPUs or specialized hardware designed for machine learning tasks. The process can take from hours to weeks, depending on the complexity of the model and the size of the dataset. Number 5. Evaluation and fine-tuning. After the model has been trained, it's evaluated using a separate set of data not seen during training. This evaluation helps to assess how well the model will perform in real-world conditions. If the model doesn't perform as well as needed, it may be fine-tuned. Fine-tuning involves making adjustments to the model or retraining it with adjusted parameters or additional data. Number 6. Integration and deployment. Finally, the trained model is integrated into the camera's hardware and software system. This step often involves optimizing the model to run efficiently on the camera's processing unit. The AI camera is then ready to be deployed in its intended environment, where it will continue to learn from new data if designed with adaptive learning capabilities. Continuous learning and updates. In some applications, AI cameras are designed to continue learning after deployment, adapting to new patterns or changes in their operating environment. This requires a careful approach to avoid drift, where the model's performance degrades over time due to changes in the types of data it encounters. Ethical considerations and bias mitigation. An essential part of training AI cameras is ensuring they are ethically designed and do not perpetuate biases. This involves careful curation of training data to avoid biases related to race, gender, age, or any other characteristic, and continuous monitoring for unintended biases in the model's predictions. The training of AI cameras is a complex, iterative process that blends data science, machine learning, and domain expertise. It requires careful planning, execution, and ongoing management to ensure the cameras perform reliably and ethically in their intended applications.